Good day. In study unit 4, we are going to continue with statistical inference, where we draw conclusions about population parameters from sample statistics that we calculate from sample data. So in chapter 10, we look at hypothesis testing for one population, and in part 1, we are going to consider these sections in chapter 10. So in hypothesis testing, we test some claim about the population mean or the population proportion, and we are going to make a decision based on the sample data then. You can think of a hypothesis test as a criminal trial, where our slogan is innocent until proven guilty. So what we currently believe is true is indicated by H0, and that is our null hypothesis, and that says that the defendant is innocent. What we want to prove in the alternative is indicated by HA, and that is that the defendant is guilty. A judge will then look at the evidence presented to him, and he can make the judgment. There's two possibilities. He can reject the null hypothesis and conclude that the defendant is guilty, or he cannot reject the null hypothesis and conclude that the defendant is not guilty. We can never accept the null hypothesis and say that the defendant is innocent, because we look at the evidence and that can only confirm or contradict the defendant's guilt, not his innocence. We will apply the same principle but statistically in terms of numerical values for the population mean or the population proportion, and we will look at the sample data then as our evidence and make our judgment. Now there's 5 steps that we apply in hypothesis testing, and these steps in chapter 10 is very important because we are both going to apply it in chapter 10 when we work with one population and in chapter 11 when we work with 2 populations. Then you must be able to distinguish between left-sided, right-sided and two-sided hypotheses. So in the alternative hypothesis, you can test a left-sided hypothesis where you want to test whether your population parameter is less than some value, or in a right-sided alternative hypothesis where you want to test whether your population parameter is more than some value, or in a two-sided alternative hypothesis whether you want to test whether your population parameter is different than some numerical value. And then in this first part of chapter 10, we are only going to test hypotheses that involve population means for large samples. A hypothesis is just a claim or a statement about the population parameter, and you should be able to distinguish between a population mean and a population proportion. Then a hypothesis test is just a standard procedure that we are going to use to test the claim about a population parameter. So we make a decision regarding the validity of the claim. As I indicated earlier, in chapter 10 we look at one population. So we are going to test single population means or single population proportions. For example, a manufacturer of car tires claims that his annual mean turnover exceeds 1 million rand. So there we test the single population mean, whether that population mean is greater than 1 million. Or Panasonic claims that 1 out of 3 households is in possession of a Panasonic product. So there we will test whether a single population proportion is different than 1/3. And then in chapter 11 we will look at 2 populations where we test 2 population means against each other or 2 population proportions against each other. For example, Toyota claims that their mean fuel consumption is less than the mean fuel consumption of BMW for a comparable vehicle. So there we test 2 population means, whether the population mean for Toyota is less than the population mean for BMW. Or the Department of Labour claims that the unemployment rate in Gauteng is lower than the unemployment rate in the Free State. So there we will test 2 population proportions against each other, The test will then involve the population proportion for Gauteng less than the population proportion for Free State. The hypothesis testing procedure consists of these 5 steps that are discussed on these pages in your textbook, but this is only a summary, so I'll illustrate the steps through an example. In step 1, we formulate the null hypothesis, which is indicated by H0, and we also formulate the alternative hypothesis, which is indicated by HA. The null hypothesis is the population parameters value that is currently accepted as being correct, and it is accepted as such until it is proven false. So in this statement, we always state that the population parameter is equal to the claimed value that we currently accept as being correct. So when we work with population means, the claimed value is indicated by mu0, and when we work with proportions, the claimed value is indicated by pi0. Then the alternative hypothesis can be stated in 3 ways. If we test the left-sided alternative hypothesis, we state that the population mean, for instance, is less than a claimed value, or if we work with proportion, the population proportion will be less than a claimed value. If we work with right-sided alternative hypothesis, then we state that the population mean is larger than the claimed value, or the population proportion is larger than the claimed value. And then when we work with two-sided alternative hypothesis, we want to test whether the population mean or the population proportion is different than some value. So you will state that the population mean is not equal to the claimed value, or that the population proportion is not equal to the claimed value. For example, an IT support manager claims that the average time it takes to solve a certain network problem is 2 hours. Then you will state in your null hypothesis that the population mean is equal to 2 hours. But if you want to test that the population mean time is shorter than 2 hours, then you will state in your alternative that the population mean is less than 2. Or if you want to test that it will take longer than 2 hours, then you will state in your alternative hypothesis that your population mean is greater than 2. Or if you want to test that the time is different than 2 hours, then you will state in your alternative hypothesis that the population mean is not equal to 2. And then for your conclusions, there's only 2 possible conclusions. You can either reject your null hypothesis, or you do not reject your null hypothesis. You never say that you accept your null hypothesis. In step 2, we specify the significance level, which is denoted by alpha, and we also give the formula of the test statistic and the distribution of the test statistic. Now, the significance level is the probability of making a type 1 error. The probability of making a type 2 error is indicated by beta, but we only concentrate on type 1 errors in this module, so type 2 errors will be discussed in more advanced statistical courses. So let's look at that practically. So if you conclude that your null hypothesis is true, and in actual fact your null hypothesis is also true, then you made a correct decision. Or if the alternative is true and you also concluded that the alternative is true, then you also made the correct decision. But if the null hypothesis was true and you concluded that the alternative is true, then you made a type 1 error. So in the criminal trial example, you would send an innocent person to jail, so you would found him guilty. Or if you made a type 2 error, then you would say that your null hypothesis is true, but the alternative is true in actual fact. So there you would set a guilty person free in the criminal trial example, for instance. Now we work with 3 levels of significance in this module. 1% significance level, then alpha will be equal to 0.01, or a 5% significance level where alpha will be equal to 0.05, or a 10% significance level where alpha will be equal to 0.1. The significance level will be given in a test or exam question, but you need to know which test statistic to apply with the type of hypothesis that you want to test. So for population means, we distinguish between Z and T. We will apply Z when we are working with large samples, and then we can use the Z table to determine probabilities in step 4. So let's quickly run through the symbols that we use in the Z-test statistic. So your X bar is your sample mean, your mean 0 is the claimed value for the population mean, and then your S is your sample standard deviation, and N is your sample size. But for T, you will have the same symbols, but here we will apply it when we're working with small samples, and we will use the T table then to determine probabilities in step 4. Then when we are working with population proportion, we will apply this test statistic. So P hat is your sample proportion, and pi 0 is the claimed value for the population proportion, and N is your sample size. Then you also need to state the distribution of the test statistic under the null hypothesis. So when we're working with Z, you state that Z follows a standard normal distribution with a population mean of 0 and a variance of 1. And when we work with T, you state that T follows a T distribution with n-1 degrees of freedom. In step 3, we will calculate the value of the test statistic. So you simply substitute the given values from the sample information to determine the value of Z or T. And just remember, for the sample proportion, that will be given by X divided by N. We already looked at this formula in chapter 9. We can then use the value of the test statistic to calculate the p-value in step 4. Now the p-value is a probability, and it's the smallest value for the significance level for which the null hypothesis will still be rejected. So imagine that this area under the curve is alpha. Now if my p-value falls within this region, then my null hypothesis will be rejected. But if it falls outside of this region, so it's larger than the significance level, then we will not reject the null hypothesis. So that's where the decision rule comes in then. If that p-value is less than or equal to alpha, we reject the null hypothesis. But if that p-value is greater than alpha, we do not reject the null hypothesis. The rules for calculating probabilities, where we looked at the areas under the curve for Z and the T tables in chapter 8, will still apply. So for example, if we test a left-sided alternative hypothesis and we had a Z test statistic, then the p-value will be the probability that Z is less than a negative Z value. So if I look at that area, I have it in my negative Z table, so I can simply read it off. But if I want to determine the probability that T is less than a negative T value, I can rewrite that as the probability that T is greater than a positive T value, and then rewrite that as 1 minus the probability that T is less than a positive T value. Since I do not have a negative T table, I only have a positive T table, and the values are given to the left-hand side of a positive T value. If we want to test a right-sided alternative hypothesis, then our p-value will be the probability that Z is larger than a positive Z value. But we don't have this probability in our Z table. We only have it to the left-hand side of a positive Z value, so we can rewrite that as 1 minus the probability that Z is less than a positive Z value. And the same will be applicable to the T table then. If we want to test a two-sided alternative hypothesis, where we say not equal to, then we will look at the probability that Z is less than a negative Z value and the probability that Z is more than a positive Z value, because it can either be less than or it can be more than if it's not equal to. So your p-value will be equal to the probability that Z is less than negative Z plus the probability that Z is more than positive Z. And since this area and this area is going to be the same, since the area under my curve is symmetrical, I can use the shortcut and I can write that as 2 times the probability that Z is less than a negative Z value. So I only need to look up that value in my negative Z table then. Or if you want to take the longer route, you can say that your P value will then be 2 times the probability that Z is more than a positive Z value, and then you will have to do the 1 minus thing. And this will also be applicable to the T table. Then in step 5, we make our decision. So there you compare the P value to the significance level, and you will decide then whether you reject the null hypothesis or you do not reject the null hypothesis according to the decision rule. And then finally you interpret your decision in the context of the problem. So there you practically write down what does it mean if I reject the null hypothesis or I do not reject the null hypothesis. And you always make the conclusion in terms of the alternative hypothesis, and I'll explain this in the example. So let's look at an example where we do a hypothesis test for the population mean working with large samples. So that means that our sample size is greater than 30. So this will be the test statistic and its distribution that we will use. In example 10.1, they tell you then, a manufacturer of a new cell phone battery claims that the mean lifetime of the battery is 30 hours. So this is our claimed value μ0, which will be 30. Then an employee claims that the mean is less than 30 hours. So that means we are going to test the left-sided alternative hypothesis. And they further tell you that a random sample of 81 batteries, so that's our sample size, renders a sample mean of 28.7 hours. So it refers to the sample mean, so it's my X bar. And the sample standard deviation of 8 hours, so that will be my S. And they ask you to test the hypothesis at a 5% significance level. So alpha will be 0.05. These are then our given values. So now we can apply the 5 steps of hypothesis testing to test that hypothesis. So in step 1, we said we state the null and alternative hypothesis. So in this case, our null hypothesis will be that our population mean is equal to the claimed value of 30 hours. And in the alternative, you will state that your population mean is less than 30 hours. Step 2, we write down the formula for our test statistic and the distribution that it follows, and then also our significance level. Then we can substitute the values from our sample data to calculate the Z value in step 3. So our Z value will amount to negative 1.463. Or if you round that off to 2 decimal places for the Z table, it will be negative 1.46. Then we can use that value to calculate our p-value in step 4. So our p-value will be equal to the probability that Z is less than negative 1.46. So we use less than because we tested a left-sided alternative hypothesis, so the sign must be the same. So we are looking for this area under the curve. We can read that off directly from our negative Z table then. So our p-value will be 0.0721. And then we can compare that to our significance level for step 5. So that p-value will definitely be greater than alpha. So according to our decision rule, we do not reject the null hypothesis. So if that is not rejected, it means that the alternative will not be true. So for the conclusion in the context of the problem, we can say that the population mean lifetime is not less than 30 hours. Or you could have said that the employee statement is incorrect. The second example is question 1 at the end of chapter 10. So there they tell you, a manager claims that the mean hourly wages paid to his employees is R7.85. So that will be our mu0, our claimed value. Then, however, a sample of 200 employees, so that's our sample size, is randomly chosen, and it is found that the mean hourly wages for the sample is R8, so that will be our sample mean, and a standard deviation of R2, so that will be our standard deviation from our sample. Test the manager's claim at a 5% significance level, so alpha will be 0.05. That is that the mean hourly wages that is paid to the employee is indeed R7.85. We just want to determine if that value is true or not. So in the alternative hypothesis, we will state that it's not equal to R7.85. So in the null hypothesis, we set the population mean equal to that claimed value, and in the alternative, we say that the population mean is not equal to that claimed value. Step 2, we write down the formula for our test statistic and the distribution that it follows and our significance level. Then we can use our sample data to determine our Z value, so that will amount to 1.061. We use that then to determine our probability value, and we are looking at a two-sided alternative hypothesis. So the p-value will be equal to 2 times the probability that Z is more than 1.06, or p is equal to 2 times the probability that Z is less than negative 1.06, since we are looking at that area and that area in a two-sided alternative hypothesis. So you can simplify that, and you look up your Z value then. So that will give you a p-value of 0.2892, or if you want to use the negative table, that will be your probability value. So your p-value will be the same. Then we compare that to alpha, and p will be greater than alpha, so we do not reject the null hypothesis. So our conclusion will be that the mean wages are not significantly different from 7.85, since the alternative will not be true and the null hypothesis will be true. Then you can try exercise 2 at the end of chapter 10, please. And please make sure that you understand hypothesis testing, because hypothesis testing will be about 20% of your exam mark at the end of the semester, because our hypothesis test can be anything from about 10 to 12 marks. Thank you.